The objective today is to explain the process someone would take to modify a hardware device. So I found this Imgur, or Imager, however you say that website's name. I found this post titled, I wanted to add a wireless Xbox 360 controllers to my N64 console, so I built this. And basically I found this guy who did just that. So this lesson, and as you can tell by the funky text color over here, this lesson is designed to be just a really fun one. It's essentially a lesson to show you how far you can go with the knowledge you learn in my classes. As I say right here, the big takeaway is you can do almost anything you set your mind to. And, of course, to give credit to the guy who created this, I just, for educational purposes, thought I'd turn his work into a lesson. So I'll introduce the guy in just a second, but let me say what his goals were. The first goal was just to get support for 4 Xbox 360 wireless controllers simultaneously. My first thought is that means we could have 4 people playing Mario Kart on this thing. His second goal was to provide support for the this rumble feature that N64 came with. So again, what? Wow, that is crazy and very cool. His third goal was to create support for the memory pack on at least one player controller. That's mind-blowing right away. I don't know how you're creating this memory on a controller. And the fourth goal was to create this fast boot up scenario. So He's looking to create a faster or equal to N64 boot up time with the controller only. Now here's a second set of goals he created that we'll go over a little bit, but not too much. So he wanted to create this general clean finish that is reliable, responsive, and practical. So anybody could purchase this modification he created. He also wanted to make sure that the original controllers were still a usable thing. And the last one was to create the ability to reset the console remotely from the controller. So that's one of the features I like the most about my Xbox One, is just from my couch. I don't have to get up and hit the button on the box in order to turn it on, turn it off, or just reset it. Though this last goal is also ironic in general, because a lot of people are still using wired controllers because they're like me, they're too poor to buy the wireless one. Nothing wrong with being poor. It's just funny that a man like this, Ryan, will go through all the trouble of connecting a wireless controller to something that was only wired to begin with. So here's his Twitter handle. You can reach out and tell him how impressed you are with his work. That's what I did. And then here's the website I got all my information from, well, most of it. He also created another site called n60-usb.com. But my school happens to block these 2 websites, so if you're watching this video here in my class, you won't be able to visit these. But if you go home and try, you should be able to check out some pretty cool things. The website I want to take you to right now, though, it does work, and it's an interesting one, because essentially you can design your own circuit boards and then have these guys, this company, create it for you. So it says here, we produce high-quality bare printed circuit boards focused on the needs of prototyping, hobby design, and light production. All our services offer purple solder mask over bare copper, so SMOBC, and an electroless nickel immersion gold finish. So these are suitable for a lead-free reflow process and are RoHS compliant. I have no idea what that means. Oh, okay, so it looks like it's a European Union thing. They seem to have stricter laws about hardware and software, well, internet use than America here. So apparently it's a protective kind of thing. A government directive to be safe, essentially. So here you have 2 choices. It looks like a 2-layer and a 4-layer prototype. You will pay $5 per square inch here and $10 per square inch there. If you come up with your own idea for a circuit board, now you know where to go to get it made. And why wouldn't you come up with your own idea for a circuit board? The guy who created this, he said it's possible to do this with other controllers, so I'm wondering if anybody in class wants to try to take this on and do it with a PS4 controller maybe. He says here that if you have some coding experience, it should be possible to add support for other controllers. I have released the source code for the Xbox 360 driver I wrote for the N360 PCB here. So if we go to his GitHub account, and my students who are in web design will be familiar with GitHub. Here's the main repository. Here's his name, so you can follow him. And the code that you saw I was just looking at is pretty cool. So up here we're talking about bits and bytes like we do in a computer science class. Down here is the actual code like we really dig into in terms of a web design class. And if there's enough interest, I can do a whole series on this code. And he does a great job, the creator of this, Ryan that is, he does a great job at commenting this code. So if, again, there's interest in it, I can whip up one of those videos. But for now, I just want to go over what he was doing with the hardware. So here's his step one. He said, I initially started with some basic prototyping. The testing ended up looking like this mess. It got to the point that I was reasonably happy with the hardware and I could design a custom PCB board. So your think right share here is, what was his first step? And this is a hint for you computer science students. This is like one of the first things we did in class. That is in August. We started with this P word. Look at that mess. I have some breadboards and stuff that we can experiment with here in class. Now this next step is a really impressive part. To understand the N64's controller protocol, and in class we study protocols, HTTP, TCP, all kinds of protocols. He said that he spent many hours with his logic analyzer and played many games to understand all the various command possibilities and the required responses for each command and the many quirks that I needed to simulate. What I say is that this photo shows a memory pack write and read of individual bits, and they're hard to make out, but you get the point. So we got ones and zeros here. It's cool because these are the bits traveling over the wire, and what you're looking at right here is milliseconds. So here's a bunch of ones in a row, and then here's a bunch of zeros, and then a one, and then some zeros again. And these are the ones and zeros starting at memory address 0. So I look forward to doing some EEPROM and maybe working with logic analyzers here in class. So your think right share, what was his second step? And if you need to go back, go ahead and go back. So the next thing he does is he says that there's several commands that are sent to the controllers from the N64 console. These all need to be understood and the correct response is sent back for it to be compatible with all games. It's not as easy as just sending what buttons you're pushing. So as a reminder, here's our buttons on a 360 controller. I love looking at electrical schematics like this. Ryan creates a schematic to use for the PCB layout. He says most of the magic actually happens on the firmware, so this part right here isn't that big of a deal. That's what he says, it's not that big of a deal. I'm like, you're whipping up schematics randomly, like that's awesome. Now here is a challenge part for you. The next step as I describe this is just way beyond the scope of this class, but I want to at least expose you to it. So here's what he says. I had a single microcontroller dedicated to all the low-level N64 controller protocol functions. This can be computationally heavy, and the responses to the N64 console must happen in real time using a custom protocol. This has a direct bus to an SRAM chip, storage chip, which acts as my memory pack. To achieve this, I implemented a fairly maybe he means powerful STM32F3 series microcontroller. So you think right share, it's a challenge. We have talked about microcontrollers in class, so as a quick check, what's the difference between a microcontroller and just a regular computer, also known as a microcomputer? And here's your hint. Some examples include a modern desktop computer, video game consoles, laptops, tablet PCs, and many types of handheld devices, which include mobile phones and pocket calculators and industrial embedded systems. These may all be considered to be microcomputers. All right, so let's talk about one of the coolest parts of this project, the wireless receiver over USB. So how did he get the wireless signal to the N64? Well, he said to enumerate the Xbox 360 wireless receiver over USB, I implemented a MAX 3421 USB host controller, which is driven by a small Atmega 328PB microcontroller. This section handles all the complex USB enumeration and polling of the Xbox 360 wireless controllers. So, to better understand this, I think, answer the question, what does USB stand for? And we'll pick up on this in just a second. First, I want to talk about some power. So how did he handle getting power there? Well, he said, finally, there is a simple power supply which takes the 12 volts available within the N64 console and converts it to 5 volts for the USB and 3.3 volts for the logic. So think right here, which direction is the power traveling? And let me give you a hint from the N64 to the N64 controller or vice versa. How will the 360 controller get power if there's no wire? And sorry if this is a low-level question. If you are smart, make sure to get this question right then. Also, don't brag too much about this being a low-level question or give me too much grief over it because, you should just spend a day on this subreddit called I Am Very Smart, and you'll see why nobody likes anybody that brags about easy questions, okay? But I thought that was a good question to make sure you're understanding how power is working in this system. So what a beautiful picture this is. This is his final PCB layout. So just take a shot at this. Tell me what you're looking at here. Now here's the real life image of that layout. He said I needed to make it as small as possible so that it could fit inside the N64 console. Due to various technical reasons, a small button cell battery is required to retain the memory pack saved games. So this is actually the same as a genuine N64 memory pack, and the battery should at least last 5 to 10 years. So think right here, where does this beautiful board go again? Just so you know, right here, this is the bulk of the work he did. And you see the little USB connector right there. So if you're enjoying this so far, there's a lot of interesting hardware hacking stuff you can do. I highly recommend this book, The Hardware Hacker. And here's an even cooler version of that exact book that I had learned about from Edward Snowden himself here on Twitter. Isn't that crazy? You can send a tweet to Snowden if you wanted to talk to that guy. But again, this is just to remind you, you can create these PCB boards as well. And if you go through this website, they're giving you the cool purple colors. So that's the fabrication, the kind of board that you're going to get if you order this from Ryan. He said along the right-hand side of the board, there is a row of solder pads which allow wires to be connected from the N64 console to this PCB for power and data. The bottom right has a mini USB socket for the USB Xbox 360 wireless receiver. So what's the USB, the mini USB here for? It's for that wireless receiver. And I really want you to look at the board here. How many wires can be connected directly to the N64 from the board? Make sure to pause on that slide if you need extra time. Here's a hint right here. Looking at the bottom of the board, you see some arrows that might be hinting at the number of wires. And this isn't that PCB board. This is the basically the motherboard for the N64. And if you remember the picture of the N64, where is it? Right here. So you got two things to plug the controller in here, 2 ports here and 2 ports here. So if we go back right here, there's two ports here, player 1 and 2, player 3 and 4. Okay, and then here's those wires actually connected. So these wires are going from the N64 to his creation. And where on his creation would they connect to? Well, here you have it. So right there along those lines, if you saw the numbers, the R for probably receiver and the G for ground, you should be able to count how many wires there are. Now I'm saying here, wait a minute, I saw 6 wires on the motherboard and I see 7 wires on the purple PCB. So what is this black wire for? You may have heard me say it, I couldn't help myself. It's G right there for ground. So you could have paused if you wanted to answer it yourself. And right there's the 12 volts power. It's nice that it says that. So right here, can you remember what this USB goes to? So the cord is plugged in now and it's going to just the end. See, it's not very long. It's just going to the end of the N64. Well, in this case, to route the USB cable outside of the case, I used a short mini USB to standard USB socket extension cable. So if your answer was to connect to a wireless receiver, you are correct, unless you're being a curmudgeon and saying that mini USB connected to a regular USB, yeah, and then he used this Microsoft wireless receiver to plug in. What a genius solution to that problem of how to do a wireless connection. So another super high level paragraph, just want to expose you to it. He said, one thing I implemented with the USB host controller side is that it is effectively a clone of the Arduino Pro Mini. So you could go to this link to buy that. And with the USB host Shield Mini, to another website, I'll take you to these two in just a second. He also says that it's 100% compatible with the Arduino USB host shield library. So this is a library of code for you to use here on the GitHub website. It made it a lot easier to develop the USB side of things, so in theory it should be possible to add support for any number of USB controllers. If you're familiar with Arduinos, the chip is just programmed with the Arduino IDE, that's the developer environment, using an FTDI serial interface, which is the same as the Arduino Pro Mini, so it's quite easy for me to debug and update. So here's those websites. This one is retired. Over here we have a lot of information about this USB host shield hardware. So once you buy this one already ready to go, so he used this library, but he created his own, okay? If there's interest in this, I can turn this into like an interactive notebook and break down the text, but this is just too much for us to read right now. All you need to know is that there's a giant library of code. There's a lot of things already done for you. So when you come up with these project ideas like this, you can make it happen without too much work. I love here in this picture, he said that once he saw that solid LED light, he knew he was good to go. So here's some information from his FAQ. What is the battery on the PCB board for? Well, the Xbox 360 controllers obviously have no slot to install a Nintendo controller pack, so I have emulated my own, which is built into the N360 PCB, so the battery is used to retain saved games that would normally reside on the controller pack, and it would have been lost if you removed the power from the Nintendo 64 console. So the original controller pack actually has a similar battery built inside for the same reason. And I want you guys to know, for any of you old school gamers, like this concept of putting a small battery inside of a game cartridge, whether it's like a Game Boy, is this a Game Boy cartridge? And then this is definitely Super Nintendo cartridge. There were batteries inside of these. And remember right here, this is the bits. This is where the gaming console can read the data from the game in order for you to play the game. So that whole battery on PCB board is a very common thing. Next up, just a little information from his GitHub website. He published the code under a GNU license. So in my class we studied the Creative Commons and how that works. So make sure to watch that video if you don't understand what this means. Another thing is that if anyone wanted extra credit in here, I would love for them to recreate this, but with an Xbox One controller. I also said earlier in the video it could be a PS4 controller. That'd be impressive as well. On his GitHub, Ryan says that with some C code experience, the information available here, and my code as an example, it should be possible to add support for any number of USB game controllers or modify my code to suit your needs. So that's a great thing about open source and GitHub, is sharing such creative stuff like this. Now in this red circle, that's already taken care of for you. He said that he used an abstraction. He is essentially using an abstraction, like all that he didn't have to worry about because it was already developed and created by somebody else. And you can benefit from the same. So that's the end of the lesson. I want you to connect it with these IB attributes. Is it a lesson that proves that you're reflective or you're balanced or whatever? I'm curious to see what you choose there. And here's the DOL. Pretty challenging, but I designed this lesson to be really fun. So I just got to make sure you did plenty of learning while having fun, okay? Your task is to recap the steps that a person would need to take in order to successfully modify hardware like Ryan did. Essentially, no matter what creative idea you come up with in terms of modifying some hardware, you should really follow these same steps. And I went ahead and got started for you. So the first step is you need to be brave enough to take on a task like this. I liked his second step where he had set goals. His third step is to create a prototype, and if you could tell me the rest of the steps, that would be great.